what's going on, guys? I'm Mr. Mills, and today we're doing evaluating trigonometric functions again, part 2. All right, so I'm going to do a similar problem to the last one we did. However, now I'm throwing 2 spices in there. I got some paprika, and I got the cayenne pepper for it. Woohoo! Steamy. Here we go. Now, I'm given this right triangle right here. I know it's a right triangle again because I have this little square right there. That tells me that, hey, that's a 90-degree angle. So this thing is certainly a right triangle. I do know that one of my side lengths is 4 and the other one is 5. The problem is I don't know what this third one is. And oh no, how am I ever going to find that third side length, right? This is the spice that I'm throwing in right now. How do you find that third side length? Pause this video right now and find out. Think about it, whatever. All right. To find that third side length, one of my favorite formulas, I say that often, that's because I like a lot of formulas, right? But this is truly one of my favorite formulas in all of mathematics, the infamous Pythagorean theorem. Oh, a squared plus b squared equals c squared. Come on. A squared plus b squared equals c squared, right? One leg of a triangle squared plus the other leg of a triangle squared equals the square of the hypotenuse. Bing, bang, boom. Here we go. It doesn't matter which one is A or B, as long as, hey, we're trying to find the hypotenuse. That's all that's important in this formula, is that the hypotenuse is on the right side by itself. It has to be all the time, okay? The hypotenuse is like an introvert. All right, so a squared plus b squared equals c squared, more like 5 squared plus 4 squared equals c squared. Okay, and then what's 5 squared? Well, 5 squared is the big old 25, right? 25 plus 4 squared is 16. So I got 25 plus 16 equals c squared. What's 25 plus 16? I think that is 41. So 41 equals c squared. Okay, good, we're done, right? This side is 41. No. C squared is 41. I need c to be by itself. I got to get rid of that squared, right? How do you undo the squared? Take the square root. An operation, right? Screw both sides. Boom. That means this side, c equals the square root of 41. Hey, it's ugly, but it's still a number. So this is the square root of 41. Look at that. Now we're getting somewhere, right? Now we got our 3 side lengths. Now we're thinking, holy crap, this problem's coming along, except, Mr. Mills, I don't see a theta in that triangle. And you're absolutely right, you don't, right? So the reason is because I don't want theta to be down here. We've had it down there many times, right? The last 2 videos have been down there. Let's throw this thing up here, okay? Now, when I ask you to do problems, I will show you where theta is. I will show you where theta is, okay? But for this problem, let's do it up there. That's fine. All right, so far I've thrown in 1 extra spice into this problem. I threw in the paprika right there, right, where you had to find the other side length. All right, now let's start finding our 6 trigonometric functions. However, I'm going to throw in another spice in a minute. Okay, so anyway, and maybe it would help if I labeled these sides. So theta is here, right? So where's the opposite side? Well, that's down here, okay? And then where is the adjacent side? The adjacent side is the one that's touching theta. So this is the adjacent, ADJ. Okay, and then the hypotenuse, of course, is always the longest side. The okay, that's the hypotenuse over there because that is the longest side of the triangle. Okay, so let's go and find the 6 trigonometric functions. You could do most of this by yourself except for one little minor detail, and we'll get to that in a second. Okay, so you'll actually see it on the first one. Okay, so to find sine of theta, right? Opposite divided by hypotenuse. So theta is here, right? So in terms of the triangle, this is my opposite side, and this is always my hypotenuse. So opposite divided by hypotenuse. So my answer for the sine of theta is 4. It is 4 divided by hypotenuse, the square root of 41. And I hope some of you were going, no, what are you doing, Mr. Mills? This is my second spice right here, right? Remember, earlier in the year, I asked you, could you divide a pizza into 2 parts? And you all said, yeah, right? And then I said, could you divide it into 4 parts? And you said, yeah. And then I said, could you divide a pizza into the square root of 3 parts? And that's what I heard. Nothing, right? Because I can't do that. No one can divide it into the square root of 3 parts. That doesn't make sense, right? That's what a fraction is. It's taking something and dividing it into equal parts. That's what division means, right? Right now I'm saying take 4 pizzas and divide them into square root of 41 parts. What? What does that even mean? I don't know. I don't know what that means, right? Square root of 41 people. Square root of 41 people want pizza. What? I don't even know. What? That doesn't make sense to me, right? Because you can't have a radical in the denominator. That's improper in mathematics. I need to get rid of that radical down there, right? How do I do that? I have to rationalize, man. I got to get rid of that square root of 41. What's the one number in the world that when you multiply something by it, it doesn't change the value? The one number in the whole world that when you multiply something by it, it doesn't change. The answer is 1. Okay, 1. And this is where we have to unleash our inner 70s disco person, right? And unleash the funky 1. Time to get funky, boys and girls, right? So I'm going to multiply to get rid of that square root of 41. I'm going to multiply the numerator and the denominator by the square root of 41. Both of it, right? And the reason I have to do the numerator and the denominator, the top and the bottom, is because when you multiply by, like, first of all, what's the square root of 41 divided by the square root of 41? Let me ask an even simpler question. What's 3 divided by 3? What is any number divided by itself? It's always 1, right? So this, square root of 41 divided by square root of 41, that is what we call a, not literally, but it's what I call a funky 1, right? Its value is just 1, it just looks a little different. It's got like a weird hat on or something, and it's wearing whatever weird clothes, right? Not maroon pride clothes, that's for sure, okay? So now I'm just gonna simplify a little bit, okay? The square root of, 4 times the square root of 41 is that's just 4 root 41. That's all there is to it, nothing else, okay? And then square root of 41 times the square root of 41, well, that's nice and simple. That just comes down to 41. All there is to it. And that's my answer for sine. 4 square root of 41 on the numerator, and then divided by 41 on the denominator. All there is to it. Okay? We have successfully rationalized that fraction right there by getting rid of that square root by multiplying by a funky 1. Okay, we're going to do that a few times here. All right, let's do cosine. Cosine of theta, right? So cosine is here, theta is here. Cosine is adjacent divided by hypotenuse. So 5 divided by the square root of 41. 5 divided by square root of 41. And then it looks like we're having like the same type of problem here. I got to get rid of that square root of 41 down there. So let's go ahead. We're going to have to multiply the numerator and the denominator by something. What is that something going to be? Well, again, it's going to be a funky 1. It's going to be square root of 41 divided by square root of 41. Okay? When I simplify this guy, the numerator is still just 5 square roots of 41. And then square root of 41 times square root of 41 is just 41. Boom. That's all she wrote. Lastly, for the main trigonometric functions, we have tangent. The tangent of theta. Tangent is the opposite divided by the adjacent. Okay? So if theta's here, the opposite 4. 4 divided by the adjacent 5. Yay! That one was much better. There was no rationalizing in there. No funky ones involved at all. And then these guys are actually going to be pretty nice as well, I think. Let's look at cosecant first, okay? So you might be tempted because you know that cosecant and sine are reciprocals, you might be tempted in just flipping your answer for sine. However, I discourage that, right? And here's why. If I took this answer and I flipped it, I would have a square root of 41 in the denominator. I don't want that. That would make my life hard, right? Okay. So what I'm going to do, I'm basically going to start from scratch. Okay. I'm going to look, cosecant is the hypotenuse divided by the opposite. So square root of 41 is the hypotenuse. Square root of 41 divided by the opposite is 4. Okay. And then there's no square root in the denominator, so I'm good to set sail. Boom, done, donezo. Secant of theta, hypotenuse over adjacent. So hypotenuse is square root of 41. And then the adjacent is 5. Okay. And then lastly, cotangent. Cotangent is adjacent over opposite. So adjacent is 5 and opposite is 4. 4. All right. All right, good deal. So I threw 2 spices at you. One of them where you had to find that the length of the side by yourself. And then the other one was you had to rationalize, okay? That's going to be all for today. I thank you all for listening. One last thing before you exit the video, I would like to point out that there is so much more we can do with these trig functions. We really can. It's just, I know a lot of people don't have calculators, graphing calculators at home, or really just any calculators that have the trig functions on them. So I'm really limiting what we're doing here. I just want to kind of give you an introduction to the trig functions, but I in no way expect anybody to be a master, per se, of trig functions at the end of this week or next week or whatever, right? In no way. So I really encourage you guys to take pre-calculus next year. If you already signed up, great. If not, at least I would suggest to take a math, but that's just my personal suggestion, okay? Thank you guys for listening. I'll see you next time, and hashtag MP.